Slides. You must have noticed that when you slide from the slider, your body continues to slide down even after your feet touches the ground. This is because your body tends to remain in the same state of motion until it felt the opposing force from the feet. Spinning top. When you rotate the spinning top, it rotates, making a number of rotations for a while to minutes, conserving its momentum due to its center of gravity. It continues to rotate until it loses its momentum, as the torque experienced on the top is more and due to air resistance force. Hula hoop. As you suddenly stop while dancing with a hula hoop, rotating it around your body, which is possible because of the centripetal force, you must have noticed that the hoop doesn't fall down on the ground or stops rotating as you stop exerting a force on it, but it actually continues to move in the centripetal motion before it loses its momentum. Tug of war. Two teams playing a game of tug of war, and if one side players applied more force as compared to the other team, then you must have noticed that the winning team player mostly falls in the direction in which they had applied a force. This is also an example of inertia of motion, where the motion of the body remains in the direction in which it was exerted. Hitting the volleyball. While hitting the volleyball, you feel the sudden impact on your hands while you are trying to oppose the force exerted on the volleyball due to gravity and the energy associated with the volleyball, and due to the movement of inertia. Running at fast speed. The athletic running at a fast speed during the race takes time to control her speed once she crosses a finish line at a very high speed. Her body tends to be in the same state of motion for a while due to the inertia of motion. Fan. You must have noticed that the propellers of the fan continue to rotate for a while even after turning off the power. This is also due to inertial motion. Stopping the vehicle. The passenger standing in the bus that is waiting at the bus stop experiences a sudden jerk backward as the bus starts accelerating. Also, as the brakes are applied to the vehicle, the passengers sitting inside a vehicle exert a forward jerk. This is due to the fact that the body in contact with the vehicle tends to remain in the direction of motion of the vehicle unless exert of certain external force. Football. Football, once kicked, travels a certain distance and comes to rest due to the frictional force exerting on the surface area of the ball by the ground and the air, which drags the motion of the ball, or when another player interrupts the direction of the motion of the football. Flowing water. The water body has immense potential energy which is converted into kinetic energy while flowing. The water continues to flow in the same direction until finds an obstacle in between its flow. Catching the cricket ball. While catching a cricket ball approaching from a height, the field keeper slightly bends his hands while taking a catch to release the impact of the force by increasing the time of catch, reducing the speed of the ball. Due to gravity, the motion of the ball is downward and the force exerting on the ball is also downward. Skiing. Skiing is an activity performed on the snow sleigh. It keeps on carrying the person standing over it until the resistive force is applied to the person. Accident. Consider an accelerating car hit on a tree. The person sitting inside the car will experience a forward jerk while the direction of motion will be still in the same direction. The body of the person sitting inside the car will be parallel to the direction of motion of the car. Once the car hits at a great force, the body of a person is still in the direction of motion of the car as it realizes the force little lately that the car has now stopped. Stirring. You must have noticed while adding sugar to your tea or making any drinks and stirring it, the mixture continues to swirl in the circular force for some time even after removing the spoon or stirrer from it. The motion of the solution is retained for a while. Coin drops inside the glass on removing the underneath card. Consider a coin kept on the card over a glass. The center of mass of the coin is pointing downward, hence upon applying the force on the card to accelerate away, the card doesn't take the coin along with it, instead of falling inside the glass. This is because the inertia of motion of the coin was downward. Hitting marbles. Upon hitting the target marbles with marble, the direction of the motion of the marble changes, but it continues to be in motion even after hitting the target marbles. Lift. When a lift stops, you must have felt the divergence from your state of rest position in the lift. Your body is in motion with respect to the speed of the lift and continues to remain in the uniform direction until your body feels that the lift has come to a rest, hence a slight force is experienced on the body. Pendulum. The oscillating pendulum continues to oscillate, decreasing the angle of oscillation at a constant rate with every oscillation. The motion of the pendulum is opposed by the air resistance acting on the bob attached to the pendulum. If there was no air drag, then the pendulum would have continued to be in the oscillation if no other external force was imposed on it. Satellites. The satellite around the planets keeps on revolving around the Earth at a constant velocity and momentum. The satellites are of two types, polar satellites and geostationary satellites. The satellite is an example of opposing the gravitational force, but to keep the satellites moving around the planet is possible only because of the gravitation force. Slipping. Have you ever slipped accidentally? Most of the time, you must have noticed that you slipped in the direction in which you were proceeding. Even after losing the momentum of your body, your moment of inertia pertains to being in the same direction as your motion. Hence, you slide forward after slipping. Object rolling on the ground. If I am talking about rolling objects, then it signifies that the shape of the object is rounded or the surface of the object is curved. The rounded, cone or cylindrical shaped objects can easily be rolled, hence some other heavy object has to be placed near it to resist the acceleration of such object. If this object starts its motion, then it continues to be in a uniform state of motion until some external agent of force is exerted upon them. Hot air balloon. The direction of motion of the hot air balloon relies upon the direction of the flow of wind. The balloon continues to move in the same direction until the force is applied to the string to change the direction of the path accordingly. Swing. The swing comes to rest either if you touch your feet to the ground or slowly by the air drag and the mass of the person sitting on the swing. Pulling a trolley. Walking with the trolley and on stopping on the way, the trolley still moves towards you a few cms as the trolley travels in the uniform motion with the force applied on it before, until now the external force is imposed on it. Car taking a turn. While taking a sharp turn, the passenger sitting inside the car bends towards the direction of a turn. Upon changing the direction of acceleration of a car, the body of the passenger in close contact with the seat of a car is thrown in its direction of motion. Forward jerk on stopping a drive or backward jerk while accelerating. You must have experienced the forward jerk of the body as you stop the bike. Your body tends to remain in the same direction of motion along with the bike with respect to its previous motion. Jumping out from the moving bus. When one jumps out from the moving vehicle, the motion of the person's body is in the direction of the motion of the vehicle. Upon hitting the feet to the ground, it acts as resistance to the motion of your body in the direction of the bus. But, your upper body is still in motion in the direction of the bus and hence you may tend to fall. Applying brakes on the bicycle. When you stop pedaling and apply cycle brake, the bicycle doesn't come to rest directly, but it is carried away a little forward and comes to rest when the frictional force acting on the bicycle tires slows down the bicycle. Kite. The kite is very light in weight and easily carried away by the air resistance force and sway in the air at a far height. The direction of motion of the kite remains constant throughout. If the kite detaches from the tread due to an external source, then it will be carried away in the air in any direction along with the speed of the wind. Skating. You must have observed the skaters jumping and landing on their skateboards though attached to their shoes. Why must they be doing so? This is to change the direction of their motion from the previous direction. Otherwise, they will tend to fall as the direction of the motion of the person changes, but the direction of motion of the skates remains uniform, which has to be changed parallel to the direction of motion of a person. Hence the skater jumps frequently while changing the direction of his motion. Frequently asked questions. Does the speed of the object moving in a particular direction depend upon the angle of inclination of the ground? The speed of the vehicle should be accelerated while driving at the steeper slopes and should keep on pressing the brake while riding down the slope. The speed acquired by the object does depend upon the inclination of the plane. The speed of the object increases while coming down from the steeper slope and decreases while climbing up the heights. What is a law of inertia of motion? The mass comes to a rest or starts accelerating when the external force is applied to the body. The law of inertia states that every mass continues moving in a straight path until exerts some external forces on the object. The body will proceed to travel in the same direction unless felt any resistive force. There are various forces responsible to keep the motion of the object alive, like air resistance, frictional force, applied force, the moment of inertia, and the center of gravity of the object also plays a vital role. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.